Okay, so for number 9, it gives us the velocity function and asks us to find the minimum and the maximum velocity. So I want to bring us to these notes here that will guide us through the problem. Anytime that you see a question that asks for the min or the max, and they don't use the words local or the words relative, then we're finding the absolute min and the absolute max. So remember, for local or relative mins and max, we're looking for where f prime changes from negative to positive or the other way around. But if it doesn't say relative, you are not going to do it that way. You're looking for the absolute maximum, and we do that in 2 steps. So first, imagine any function. Your max can occur somewhere in the middle of the graph, right here. Actually, like our min is occurring in the middle of the graph, but our max could be at one of our endpoints. Here's another big clue that you need to use this method when they give you endpoints by giving you an interval, right? So if we're looking for the max or the min, we have to consider the endpoints and the critical points. The critical points are where f prime of x equals 0, or, I can't believe I forgot to write this, so don't forget, or where it does not exist. Here's an example of where a max occurs where the slope doesn't exist. Boom, sharp corner. Or it could be where the slope equals 0. Boom, a min at the relative min. But like we said, it could also occur at the endpoints, so we consider all of those things. Okay, memorize this. We consider endpoints and critical points. So the way that we get our critical points is whatever we're trying to find the max or min of, let's call it f of x, we take its derivative and set it equal to 0, or its derivative where it doesn't exist. Next, we take all of the points we've come up with, and then we evaluate the function at those points. So then we basically plug those in. Let's say our endpoints were a and b. We're finding f of a, f of b, and then any of the critical points. We'll plug those in also. Then we'll simply select our max and our min based on the y values we come up with. Okay, so we want the max or min velocity over this interval. The fact that they're giving me endpoints immediately clues me off that I need to do an absolute. What we're doing is an absolute min or max problem. And so for absolute min and max problems, number 1, we consider endpoints and critical points. And then number 2, we evaluate at all those values. Let me go into airplane mode. Okay. So the endpoints in this case are 0 and x equals 4. And our critical points will occur where the derivative is equal to 0. So since we want the max and min velocity, we have to take the velocity's derivative, which, as you remember, is acceleration, and set that equal to 0. 3t squared minus 6t minus 9, and I'm setting that equal to 0, or seeing where it doesn't exist. Since we have a polynomial, there is no place where the derivative won't exist. If, let's say, I had something like this, then x equals -2 would be one of my critical points because the derivative doesn't exist at -2 because I can't divide by 0. Okay, but we don't have a situation like that right now. So let's factor. I can see that I have 2 critical points. I have at t equals 3 and at t equals -1. But bring it back to your interval that you're interested in, from 0 to 4. So that means that -1 won't be something we need to even think about. So we've figured out our endpoints are 0 and 4, and our only critical point is 3. Let's see how the graph, where the graph is at each of these places. So if this was step 1, I'll do step 2 over here. Okay, so we have to plug these back into the original function to see where's the velocity the highest and the lowest, the max and the min. So let's start with v of 0, which is 0 cubed minus 0 squared minus 0 plus 1. Okay, velocity at 0 is 1. Let's find v of 4, the other endpoint. So it's 4 cubed minus 3 times 16 minus 9 times 4, which is 36, plus 1. That's 64. Okay, so 64 minus 48. I'm borrowing. Okay, that gives me 16. Minus 36 is negative 20, plus 1 is negative 19. Cool, so I'm just going to box these so I don't lose track of them. So far, my max is v of 0, and my min is at v of 4. Then let's see what happens with the velocity at 3. So that's going to be 3 cubed minus 3 times 3 squared, which is 9, minus 9 times 3, which is 27 plus 1. So it's going to be 27 minus 27 minus 27 plus 1. These cancel, leaving me with negative 26. Great. So we can now compare these values and write our conclusion. Okay, so we can say the maximum velocity is 1 at t equals 0. We can say the minimum velocity is, now the velocity is the number we ended up with. It's negative 26, and it's occurring at time equal to 3. And we are done.